Hello Algebra 2 students, and welcome to our video on with practice with nonlinear systems. This strange meme that you see here is mostly for Bryce. I'd never seen that one before. He showed it to me yesterday, and at first I looked at it and I was like, right. Anyway, let's practice with some nonlinear systems. Okay, you have your paper. We're going to practice 5 of the ones on that paper. Okay, so 1 through 21, you've got the extras, and I can give you an answer key for those. I don't have any problem writing that out. But we're only going to do 5 of them in the video. 1, 4, 5, 12, 16, and 17, which I've set up on the next 5 slides. You can pause it and do them, or you can do them with me, but either way, I do want you to go ahead and make sure you understand how to do this by the end of the video, and bring your questions to class that you're unsure about. This should be a rather quick video as our videos go. Okay, so our first one here is x squared plus y squared equals 2. This first one up here is this first equation right up here, this one. This is a circle with a radius of the square root of 2, and this is a line. So the maximum number of solutions that we're going to be able to have here is 2. I'm going to use substitution for this. So that means that I'm going to solve this bottom equation. Let's do it for x. So 2 minus y, or negative y plus 2. Either way, that's what I'm plugging in for x. So 2 minus y, the quantity squared, plus y squared equals 2. And so we're going to FOIL. So that's first, let's see, I didn't mean to say FOIL, square the binomial. So square the front, square the back, double that middle product, so minus 4y in the middle. And so now I have 2y squared. So let's simplify that down. Sorry, I know I always forget that I can't move the iPad for fear that I'm going to make a bunch of noisy feedback. So I think I just did that, and I apologize. Okay, so let's subtract that 2. So I have 2y squared minus 4y plus 2. And remember that when you're solving a quadratic, yes, I know, another quadratic equation to solve, you can divide off all that 2 there. So if I divide off all the 2's from each term, we're going to get this, which is factorable. It's y minus 1, the quantity squared. So we are not going to have 2 solutions to this. It's only going to be one ordered pair because there's only one possible value here for y. If y minus 1 is the only factor, y minus 1 equals 0 and y equals 1. And we can plug it in. 1 plus y equals 2. And that means y equals 1 as well, and that means this is a circle and a line that are tangent at the point 1, 1. You should remember the geometry word tangent. So you got your circle at the center, and they're tangent at the point 1, 1, and this is this line right here. And that's where they cross, right there. Awesome. Next one. Okay, on to number 4. 9x squared plus 4y squared equals 36. That's an ellipse. I know that because these two numbers are different. You have both x and y squared, and then you get your 36 over here. And I know this ellipse actually, I know exactly what it looks like. I know that it centers at the origin, and it's about like that. You'll learn more about that next year, but not that that really matters right now. But the other equation here, this is a line. So we might have 2 points, 2 solutions, and we might have 1, and we might have none. Okay, so this one is going to be a little bit on the ugly side, a little bit on the unpleasant side. So let me dig right in. I'm going to start by solving the second equation for y. So it's going to be negative 3 halves x plus 3. So that's what I'm going to be plugging in for y. So I have 9x squared plus 4 times the quantity, negative 3 halves x plus 3. And that is just plain unpleasant with the fraction there, isn't it? But that's no big deal. We can handle this. So square the front, square the back, double the middle product. My 4 there. Square the front's going to be 9/4 x squared. Big space. Square the back's going to be 9. double the middle product. So the middle product there is going to be 3 times negative 3 halves. So I want that times 2. That's what double the middle product means. Well, the 2's are going to cancel, so that's convenient. So that's negative 9. So it's minus 9x. And that's a positive 9 there. Okay, a whole lot of 9's going on in there, isn't there? A lot of 9's. And then when we multiply by 4, we're going to have 9x squared plus, those 4's are going to cancel, 9x squared again, minus 36x plus 36 equals 36. So 36's are going to cancel because it's the same number on both sides. So I have 18x squared. This is turning out to be not that difficult at all. Just those hideous fractions in between. Take out the 18, we have x, or 18x I should say, leaving me x minus 2. So my solutions for x are going to be 0 and 2. And I'm going to plug them back into my linear equation. Plugging in 0, sorry, my mind completely blanked out for a second there. 2y equals 6, so y equals 3. So when x is 0, y is 3. It's good to go ahead and write the ordered pair at that point, because if you lose track of which value you plugged in for x, it can be a real pain in the neck. Alright, 6 plus 2y equals 6. Well, the 6's will cancel, same number on both sides. 2y equals 0, so y must equal 0. So there's our 2 ordered pairs. And so we have a line passing through an ellipse at 0, 3, and 2, 0. Like that? I think that's it. Interesting. Very, very interesting. All right, next one. Okay, now I have, this is a line and a parabola. So let's think about what that could be. That could be the parabola and the line tangent. It could be the parabola and the line where, just pretend that's tangent, pretend it's just touching. The parabola and the line where it goes right through it, or it could be a parabola and a line where they don't even cross. So in this situation, really the only way for me to do this is going to be substitution again. So if I solve this for x, I'm going to have 2y minus 4. So that's what I'm going to plug in here for x. So y squared equals 2y minus 4 plus 3. Let's get everything on one side. I have y squared minus 2y minus 4 plus 3, that's minus 1. So when I move it over, it's a plus 1. So we got y minus 1, the quantity squared again. So y equals 1. So it looks like we're only going to have one solution to this one. 2 times 1 equals x plus 4. Subtract the 4 from each side, x is negative 2. So negative 2, 1 is the ordered pair where the parabola and the line cross. That's 3 questions down. We have 3 more to go. I think I might have said 5 at the beginning of the video, and I totally picked 6. Let's see how we feel about 5 before I... Okay, so this one is hyperbola. This is a hyperbola. I know because of the minus here. That's the big reason I know. And this is a parabola. So we got a lot of different ways that could come out. A hyperbola, remember, has this opposites direction thing going, like the 2 lines on a tennis ball. And then a parabola, so let's see. The parabola could not even touch it, like that. The parabola could pass through one of them 2 times, the other one 2 times, could pass through, there could be 4 ordered pairs. I mean, there's a ton of possibilities here. So let's work on actually solving it and get rid of that. There we go, that ugly diagram over there. Okay, so if y equals the quantity x squared minus 3, that's what we're going to replace y with. So x squared minus the quantity x squared minus 3 squared equals 3. So it looks like we're going to have a 4th degree polynomial on our hands. So here, x squared minus, don't worry about distributing the minus yet. Let's multiply this out. X to the 4th, so square the front, square the back, double the middle product. There we go. Equals 3. All right, so we'll distribute our minus. So I have x squared, oops, sorry about that. X squared minus x to the 4th plus 6x squared minus 9 equals 3. So let's see, negative x to the fourth plus 7x squared, and then minus 12 equals 0. So it's x to the fourth if I multiply everything by negative 1. Oh, sweet. It is factorable. Okay. It's totally factorable, but we've got a whole bunch of radicals on our hands here. So first I want to notice this is one of those where I could replace x squared with a and make this a squared minus 7a plus 12 and factor that. And that's where I should recognize that I'm going to have x squared minus 4, x squared minus 3 equals 0. Whew. So we're going to end up with 4 solutions here. And the reason I know we're going to have 4 solutions on this system is because we end up with this 4th degree polynomial right here. Okay, I kind of jumped over the using the a part, but hopefully we all grasped that quickly. Now, what are the 4 different values for x? Okay, if we didn't, just tell me in class. We'll go over it again. What are the 4 different values for x here? Well, x squared minus 4, we can either factor it as a difference of squares, or we can recognize that if we solve for x, we're going to have plus or minus 2. And we can do the same thing with x squared minus 3. Except on that one, we have x squared equals 3, not a perfect square, so we have x is plus or minus the square root of 3. Then you're going to want to go back and plug that in, all 4 of those different possibilities, to one of these 2 equations. Now the great thing is both equations have x squared in them. So if I square x here, it doesn't matter which one I square, I'm going to get 4. And same thing here, it doesn't matter which one I square, I'm going to get 3. So it turns out that we're going to have 4 solutions here. Excuse me, wait a minute. 2 solutions here. 2. Maybe. I don't know. Might be 4. Let's try it. Let's try it. Okay, so y equals, doesn't matter, positive or negative 2 for x squared minus 3. All right, so in this case, y equals 4 minus 3, which is 1. So that's 2 different ordered pairs. That's positive 2, 1 and negative 2, 1. Because it doesn't matter which one I plug in, I'm going to get that positive 4 right there. And then for the other one, I'm kind of out of space there. I don't want to bunch it up. It's going to be plus or minus the square root of 3, the quantity squared, minus 3. So that's 3 minus 3, that's 0. But again, that's 2 ordered pairs. That's square root of 3, 0, and negative square root of 3, 0. All right, moving on. Okay, we have 2 more, and I was thinking I was going to shorten the video, but now that I got to this one, that may not be necessary. So let's jump right in, and we are going to solve for this y right here. So that y equals x squared minus 5. Now it's going to be another 4th degree one. This is probably going to be our last one, so I may not do 17. Although you guys can fast forward through the work to look at the solutions if you've already done the problems yourself. So x squared plus, and we're plugging in for y, the y squared minus 5. And we've got to square it. So x squared, x to the 4th, x squared plus x to the 4th minus 10x plus 25 equals 25. So our 25s are going to cancel. So x to the 4th plus x squared minus 10x. So actually equals 0. So actually this one's a little bit different. Sorry, I keep hitting the bottom of this with my palm. Just doesn't want to do what I want it to today. So if I pull out an x, I'm going to get that. Oh, that's awkward. I definitely feel like I did something wrong with this one. Let me stop here for a second and pause it and think about it. I found my mistake. It was supposed to be minus 10x squared right here. This right here. And so now we have this. And that's actually much better. Because now, I apologize for the scribbly. I don't like to do the whole scribbly thing there. But I didn't have a choice. I couldn't erase. The limitations on this app sometimes tick me off. Alright, so I can factor out an x squared and look at that. That means I have 2 solutions of 0. Which still only indicates 1 ordered pair with an x of 0. And then this is a difference of squares, or we can say x squared minus 9 equals 0. So x equals plus or minus 3. So it looks like we're going to have 3 solutions with this one. So a parabola and a circle, that makes sense. Parabola passes through the circle 2 times. All right, so if I plug in a 0 for x squared minus y equals 5, so negative y equals 5 or y equals negative 5. So 0, negative 5, one solution. Plug in 3, and it doesn't matter whether it's plus or minus 3, and we square it. Minus y equals 5, that's 9, minus y equals 5, that makes y equal to 4. So that's 2 different ordered pairs. That's 3, 4, and it's negative 3, 4. So there's your 3 ordered pair solutions for number 16. One more. I know it makes the video long, but you'll get over it. Okay, so this system here is a great one. I'm going to multiply the top one by 3, and that's going to cancel the y squareds. So 3x squared plus 3y squared equals 75. 2x squared minus 3y squared, and there's the cancel-y part, equals 5. Cancels out. 5x squared equals 80. Divide both sides by 5. X squared equals 16. How convenient. X is plus or minus 4. So we're going to have 4 solutions for this one. I can tell that because I have 2 solutions for x, and both the x and the y are squared. So this is a hyperbola and a circle. And to give you an idea, say that's the circle. That's what a hyperbola does. So that's like the tennis ball type setup. So doesn't matter whether I plug in a positive or a negative 4 because I'm squaring it. And it doesn't matter which equation I'm using here. But we have 4 in there. It gives me a 16 plus y squared equals 25. Subtract the 16 from each side. Y squared equals 9. How convenient. Y is plus or minus 3. And then you have the 4 ordered pairs set up. So you can put in for x 4 and negative 4, 4 and negative 4. And for y you can put in 3 and negative 3. And there you go. Hope you enjoyed the practice and the iTunes radio and the Dogue. You're welcome, Bryce. See you guys in class.